Splunk, how it works. So we can see here different data sets of chunk 1, chunk 2, chunk 3, chunk 4. So these are the different indexes stored in the Splunk. When any data that comes into the Splunk, it will note the timestamp of its data. The time is very key here. That timestamp specified data is called as an event. That is called as a Splunk event. Here, the Splunk sets the data events basing on the time. So it puts the bundle of events that have occurred during the particular time. So that is here called as a chunk 1, chunk 2, chunk 3, chunk 4. For example, if you want to run a query failed password entry, that means that when user enters a password, it might be an incorrect password or inappropriate access to the any trying of this hacking things. So that means that password will get failed in the first attempt. So when you search for failed password keyword in the Splunk, it will go and search with this failed password keyword in different timestamps, that is different chunk of datas. So 1, 2, 3, 4. For example, in this diagrammatic case, when the user fires a command to know about the events that contains the failed password, so when the query goes inside the chunk 1, chunk 2, chunk 3, chunk 4, the query maps to bring up the statistical data out of this source data. Then that is reduced and merged by reduce function and give out the answer stating how many failed password events are identified during which timestamps. So that map reduce function is key here. Moving on to the scalability of the Splunk, when your business grows drastically, you need much bigger Splunk instances running to manage the data that is getting hugely generated by different machines, different servers, etc. So, in that case, one server can't handle all the data incoming there. So that need to be distributed into different servers. Sometimes these servers lie in different geographical environments where you need to correlate all the data from different servers using the Splunk. So, for example, you have a multinational company and you want to identify the failed password attempts across all the regions. So, for example, you have your company in India, USA, Europe, Australia, etc. So, you have in the four regions. So, you need to identify the failed password cases from all the four regions, and you have servers running independently on each region. So, each server will have its own chunks of data, its own timestamps, its own events. So, now we need to get the data from all the servers. The correlate answer should be the final answer. So in this case, the map function maps individually in each server and then it will reduce to the final output coming from all the servers and gives us the data and showing what all the failed password cases from all the regions. So in this way, the Splunk can scale itself from a single instance to multi-regional instances. So that is the advantage of this Splunk, and we call this as a distributed environment. The environment which lies in different regions, widespread over across multiple regions, is called as a distributed environment. So to summarize what we have learned in this video is that the background of different versions of this Splunk, where the capability of the search grown from 10 to 100 results to millions and millions of results occurring for any query that we fire in a distributed environment. How did they do that? So the main principle, the driving principle behind this is called as a map reduce principle. So that is initially introduced by Google in 2004, and that is acquired, the usage is acquired into the Splunk by 2009. So how does this map reduce works? So map reduce divide the problem into two parts. One is the map function, other one is a reduce function. So map function process the source data into sufficient statistics and reduce function merges all the statistics to give us a final answer. So that is our desired output. So in this way, the principle of parallelization is also key here. By this parallelization and map reduce phenomena, the Splunk is very fast, very independent on data processing and visualizations.